So, this is my first video in a while. I'm glad to be recording again and I hope you're excited to watch it. Today we're looking at factoring quadratics where a equals 1. So just a little reminder, when I say a equals 1, what I'm talking about here is we're talking about quadratic trinomials. Okay, quadratic trinomials, and so the general form there is ax squared plus bx plus c. And so notice that we have a trinomial. It's quadratic because the highest term degree is 2, and then these are just coefficients here. And of course, what's the power on here? That's a 1. What's the power on this one? Well, it's x to the 0th, but we don't write that. But we just need to remind ourselves in our heads. We just need to remind ourselves that x to the 0th is there, and that this little 1 is here. That's how we make sure that it's look at the full form of the polynomial. We have a quadratic term, we have a linear term, and we have a constant term. So these are just coefficients essentially. And when I say a equals 1, I'm talking about this a right here. When that a equals 1, okay, when a equals 1, it looks like this, just x squared plus bx plus c, right? So that's what we're looking to factor today. And I'm saying a equals 1 because when you have a quadratic trinomial where a is not 1, it actually works a little bit differently, and we're going to be looking at those in our next topic. So not this one right here, but next week we'll be doing our next topic will be where a is something other than 1. But for now we're just doing this. Okay, so we have an x squared and we have some linear term with a coefficient and some constant term. So that's what we're looking at. Okay. So here I've started out by doing this one, which actually is a difference of squares. If you notice, this is n squared and this is 49, which are both squares, and it's a difference of squares, which we're going to learn when we do special cases. But essentially, what I want you to think about this, I want you to think about this as n squared plus 0n minus 49. Do you see how those are the same thing? And so what we're going to ask ourselves, this is really the key today, and so because it's so important, I'm going to write it on a bright orange piece of paper. So here's what you're doing. You look for two numbers, and when I say numbers I mean integers, because all we're doing here are integers. Okay? You look for two numbers that have product C and sum B. So you want two numbers that you can multiply and get C, and when you add them you get B. Okay? And be sure to think about plus and minus. Okay, be sure to think about plus and minus. And so when we go through these, I'm going to be making a little list here, and that will help us see what we're doing. So here I'm looking for numbers that are, when I multiply them I get negative 49, and when I add them I get 0. Okay, so of course the numbers that come to mind are 7 and negative 7, okay? Because when I multiply those I get minus 49, when I add them I get 0. And so what you do with this is once you've identified these numbers, you go straight into two binomials that are multiplied, here and here, and your n goes there. Essentially what we're doing here is I should have started out by saying this. When we're factoring these things, factoring quadratics with a equals 1, this is FOIL in reverse. That's all we're doing here, is we're doing the FOIL method, but we're doing it in reverse. Okay? So we have our two binomials here, and one of these numbers comes in here, and one of these numbers comes in here. It doesn't matter which one goes first because these are being multiplied, and multiplication is commutative, so the order doesn't matter. And so we have n plus 7 and n minus 7. And if you were to FOIL this, and I would encourage you to stop the video and try foiling that, and you'll see that if you go in and FOIL that, what you're going to get out of it will just be what we started with. And that's the whole point of this, okay? When you FOIL it, you get that again. And that's what we're trying to go for here, okay? Now let's look at one that actually has a middle term, b squared minus 16b plus 63. Now this one may look a little bit more difficult to get your mind around, but it follows the same process. We're looking for two numbers that when we multiply them we get 63, and add them and we get negative 16. So 9 and 7 pops into my head because 9 and 7 is 63, and I can see where I get a 9 plus 7, I get 16. And it's just important here to start thinking about flexibility with the negatives, I'm going to call it. So be flexible with your negatives, okay? What we notice here is that if we have negative 9 and negative 7, multiplying them gives you 63, adding them gives you negative 16, okay? And so again, we're just going to set up our two binomials, and one of these numbers is going to come in here, and one of these numbers is going to come in here. So we're going to have b minus 9 times b minus 7, okay? And that's it. That's what we're doing here. All right, let's do another one. Two numbers that multiply to give 6 and add to give negative 5. Well, it's negative 3 and negative 2, right? If I multiply those, I get plus 6. If I add them, I get minus 5. So I'm just going to set up my binomials. This goes in there. This goes in here. So n minus 3 and n minus 2. Okay, this one you may go, oh, but Alex, I gave you one that has a equals 4. The leading coefficient is 4. But what you can do is you can factor that out using GCF, which we've already done. So if we pull out the 4 as a GCF, we're left with x squared minus x minus 30. And now this 4 can just come along for the ride out front, okay, and then we're just doing this like we are doing everything else on the page. So we just drop down the 4, okay, and we have two, we're looking for two things here. We'll have an x to factor the trinomial. I'm looking for two numbers that multiply to negative 30 and add to negative 1, because remember that's a minus 1 right there, right? So I quickly see that it's negative 6 and plus 5. If I multiply those, I get minus 30. If I add them, I get minus 1. And so one of these is just coming there. One of these is coming there. Again, it doesn't matter which one is which. I have a minus 6 and a plus 5. And this whole thing here is my answer with the 4 in it. Okay. Let's do this one here. Adding to get 9, multiply to get 8. Well, 8 and 1 will do it. So it's n plus 8. And n plus 1. Here, what about negative 10 and negative 2? If I multiply those, I get plus 20. If I add them, I get minus 12. So I have n minus 10 and n minus 2. What about this one? This one looks a little tricky. This is n squared plus n plus 0. So I need two numbers that multiply to 0 and add to give me 1. Well, clearly it's 0 and 1, right? So I have n plus 0 and n plus 1. Well, n plus 0 is just n. So I have this, which as you can see, if I had started out by just doing GCF and pulling the n out, I would have gotten the same thing by GCF. So, there's no coincidence there. It's because there was a zero constant term. Okay. Here, what about negative 5 and positive 9? When we multiply those, we get minus 45. When we add them, we get positive 4. If the negative and the positive choices are confusing you, just write them out. Say, oh, well, would it be negative 9 and positive 5? No, because that's going to give me minus 4 when I add. So you kind of just whittle your way down, and after a while, you can start doing it in your head. So here, not n, excuse me, the variable is k. So we have k minus 5 and k plus 9. Here, what about minus, see, here we go. I'm doing this now. What about minus 8 and plus 1? If I multiply those, I get minus 8. When I add them, I get minus 7. And that was even tricking me a little bit. So, sometimes you get a little stuck, and that's perfectly fine. Okay. Plus 1 right there. I'm thinking a negative 9 and a positive 10. Negative 90 when I multiply. When I add, I get plus 1. So it's r minus 9 and r plus 10. Good. A couple more on the back here. I'm going to skip some of these that don't have a coefficient. Let's pull this 6 out there. Whoops, except I'm just changing signs. 5r minus 6. Yeah, so now I'm looking in here. I'm just going to factor this, and this little 6 is just going to coast down on the front. Right? So what do we got here? How about a minus 6 and a plus 1? Right? Minus 6 and plus 1 would give me minus 5. Multiplying would give us a negative 6, so there's that. I'll do one more here. This one here. We'll pull the 3 out. Right? And so what have we got? Multiplying to 9 and adding to negative 6. Well, it's got to be negative 3 and negative 3, right? Because when I multiply those, I get plus 9. When I add them, I get negative 6. Minus 3, minus 3. So notice here, this is actually n minus 3 squared, right? So there you go. Okay, that's it for the video. You can try some on your own now.